So moving on to the next concept, in this video we will understand about the mean. So start making notes with me. Main heading, this is mean. We'll first talk about the ungrouped data. So if you have seen my first lecture on the data analytics, so you will know what is a ungrouped data. So x2, x3, x4 up to xn. So if we take the mean of these elements, we know we do x1 plus x2 plus x3 plus x4 plus x5, continuing like this up to xn, and we count this how many are there. Accordingly we will divide it from that. This is called the mean of ungrouped data. This is nothing but the average of all. Think of a data and pause the video. You need to comment it out in the comment box. Mention the data you have taken, then calculate its mean, then write the answer in the comments. So this is the mean, and mean is written as x, a bar in the above the x. So you can simply write it in the mathematical form like this. If you know, this is the symbol of sum. Sum is calculated from I equal to 1 up to n. I equal to 1 up to n. I equal to 1 up to n. This is, and I is written as xi by number of elements in that group data, that is n. This is the formula of ungrouped type of data and its mean. Next is, we have talked about two types of ungrouped data. This is type 1 without frequency. Next type is with frequency. So in the previous video I have told you that what is the frequency, what is the meaning of the frequency. If you didn't know, you can recall the previous video again. So if we take a data up to xn and its frequency is f1, 2, 3. Frequency is nothing but the times of the repetition of xi. f2 is nothing but the times the x2 is repeated in the data. f3 is nothing but how much times x3 is repeated in this data. So moving on, if we calculate its mean, we will multiply the times of here in the type 1 you see that we dose the number of sum of all data by number of data, number of elements. Suppose this will be also like that. If we convert this type of data into the type 1 type of data, we can simply write it as xi, suppose 3 times there is xi, not 3 times, write it as, suppose it is f1 times, and x2 is also like that, up to times. Think of like that, and well, let it. Here there is x1 times of x1 is of 3 types, x2 is of 2 times, x3 is of 4 times, x5 is of, suppose x4 is of 3 times. So what you will do according to the type 1, here you will take the sum of all these elements and divide it by 2. So if we do that one, x1, so x2 plus x2 plus, this is x1, x3 plus x3 plus x3, and it goes like that, continuing, and divided by number of elements. Suppose here is 1 2 3 4 5 6 7 8 9 10 11 12. Suppose here we have 12 elements. So further we do this, we can not just write this one like this, we can multiply this like one. You can skip this part if you know, skip for 1 minute, you will reach the what you need. So if you don't know, then for remembering, I don't remember anything. I just simply think of the thing, how it was actually doing inside that one. So you will get a deeper sense of the study and you will like the study. So here x2 is repeated for 2 times, here it is repeated for 3 times. Okay, here it is repeated for 2 times, here take off another x3 is repeated for 4 times, and these 3 2 4 are nothing but the frequency of f1, how much time the x1 is coming. This 2 is nothing but the how much time the x2 came in the data. This 4 is nothing but the x3, how much time the x3 came in this data. So now if we derive the formula, we can simply write it as x1 into f1 plus x2 into f2 plus x3 into f3 plus, it will continue like that, and it will last as xn into fn by what will be the what will be the number of elements. If you count it here, these are nothing but the sum of this one. So 12 is nothing but 12 is nothing but the sum of this one, all the elements. So if we do the sum of all the frequencies, suppose take off that x4 2, x4 is of 3 times. So if we do sum of all the frequency, this is 3, this is 2, that is 5, 5 plus 4 is 9, and 9 plus 3 is 12. So here you know this is nothing but the sum of the frequency, that is equal to 12. So in the formula you can write this is nothing but f1 plus f2 plus f3, it goes up to fn. Okay, this is the logic behind that. So now mathematically we can write it as sum of xi, fi, and I starts from 1 up to n, goes up to n, and the lower will be sum of fi. Sum of fi will be I equal to 1 to n, and this is your data. This is your formula. I am creating this video in too basic, as this concept will be used in Python. If you didn't know these things, what it's going inside the data, simply just learn and move to the next. You will struggle a lot in previous means in the upcoming classes of Python. So you need to know about the deep meanings. So moving on to the next, we will talk about group data. This is the second type. So take up an example, class interval. I taught in the previous video what is class interval means. This is the frequency, and another thing we will write here. So left space for that one. So the class interval is 1 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. Suppose its frequency is f1, f2, f3, f4, f5, f6. So to calculate its mean, you need to do something like mid value. Mid value is like this one, this thing. What is the data? So here we take the average of the two intervals, upper and lower limit, and divide it by 2. So this is, suppose xi, we write it as like this. So 0 plus 10 by 2, it will be 5. Next is 10 plus 20 by 2, it will be 15. Next is 20 plus 30 by 2, it will be if I have done any mistake, let's consider it. It will be 25. 30 plus 40 by 2, it will be 35. 40 plus 50 by 2, it will be 45. 60 50 plus 60 by 2, it will be 55. This is the whole concept. Moving on to the next, how to calculate the uh, how to calculate the mean of this data, we will continue like this, taking this data here. Now we can say that this data is converted to the type 2 of ungrouped data, isn't it? So we can write it as x bar equal to the mid value and the frequency. The mid value and the frequency. 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 And the denominator will be sum of all the frequencies. Then write its formula is for group data sum of x mid value into its frequency fi by sum of fi. If you think of the difference between the two, the type 2 of the ungrouped data and the this one, we converted this into the interval format. I have told you how to convert the this type into interval form in the previous lecture, so you can watch that one. So if we do in the interval format and take its mid value, the value of uh, the value of the frequency, uh, the value of the xi differs from the mean of the type 2 and group data type. So this is approximate value. This is not exact. Okay, this is the whole thing. We will now take a example to justify what I said now is the difference between when we find the mean through the type 2 formula and with the group data when we convert that the same data in group data form. What is the difference in the two? We will calculate it now and show you the difference. Okay, suppose firstly think of an experiment having only 5 numbers, then 20 without repetition. This is ungrouped type of data. 10, 20, 30, 40, 50. Now find its average or the mean. X bar equal to 10 plus 20 plus 30 plus 40 plus 50 by number of elements in this, that is 5. So calculate it, comment out. So taking next data, grouped data. Group data, first we will take up this from the stage we have. So thinking of like the type 2 of ungrouped data we are considering like this, then I will show you how we are converting this one to the group data type. So taken data with repetition, think of simple values 10 10 10 10. No, let it. Suppose think of any arbitrary 5 10 48 20. Next is 8 23 32 30 5 10 28 19 10 12 40 45 47 48 12 10 13 15 10 25. Again a 40. So count the numbers. N will be 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 19 20 21 22 23 25. N is 25 here. Okay, N is 25 here. So now mean equal to sum of all this data, plus 48 plus 20 plus 8 plus 23 plus 32, do it up to 40 by the number of elements. Do it using calculator. Stop the video and do it using calculator. So I think you have done this. Suppose this is like 5 by 5, I think so. Please divide, check. You need to check, and if I am wrong, you need to comment. I'm doing this only to make you understand, nothing calculation or the thing we are doing here. You need to do your calculation on your own. So now we are converting this type 2 type of ungrouped data to group data to group data. So this is like this: the class interval, frequency, and mid values. Suppose this is 10, then 20 to 30, 30 to 40, 40 to 50. Take this value, write something, check from your notes and put how many number of elements are there in between 0 to 10. I calculated it. Pause the video, do it by yourself, then continue the video to check the values. This is 9, this is 4, this is 2, this is 6. Now in the group data we take the mid values of this. So this is 15, this will be, sorry, this is 5, this will be 15, this will be 25, this will be 35, next one will be 45. Okay, now we will take these values and find its average or the mean. So we will do the step frequency multiply the element by total number of frequencies. So the first element is 4 into 5 plus 9 into 15 plus 4 into 25 plus 2 into 35 plus 6 into 45. Okay, then divide it by its frequency. Number of elements is 25. So here the average we got 23.8 approx. I think this is correct. So now if you calculate the error, because here you got 22.5 for the same data, and here if you convert that data in the form of group data, you get something like this. So the error here will be 23.8 minus the previous answer 22.5 equal to 1.6. This is the error when you convert. This is the error. This error always comes when we consider the group data case. When you convert a data from ungrouped to grouped. I'm giving you an question, so you need to do it as an homework and write the answer in the comment section. So you have a data with class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Okay, with frequency 3, 5, 7, 9, 4, sum is 28. The mid value you need to calculate. This is your homework. This is a very easy thing. You need to calculate this one and comment. For this video this is enough, I think, and in the next video we will see 3 properties of mean, then we will proceed. So I am thinking of making the video itself here so that you will get the total mean concept in a single video. It will be easier to you also and me also. So I need you to pause the video here and comment the answer, and we will now continue with properties of mean. Before that, I recommend you to take a break of 2 minutes and then continue. So continuing our video here, we will start with properties of mean. Properties of mean. Okay, the first property of the mean is sum of deviation of observation from there, the sum of the deviation of the observation from their mean is 0. You need to remember all this, okay? Sum of the deviation of the observation from their mean is 0. What it's want to convey? Suppose we have a data x1, x2, x3 up to xn, and its average is x bar. This is the mean or the average mean. So if you need to take the sum of all the elements xi minus x bar from I equal to 1 up to n, you will get 0 as the outcome. Sum of the deviation from the observation, these are the observations, these are observations, this is the mean, and these are sum. So overall we will say it as deviation. Okay, the sum of the deviation of the observation from the mean is 0. If we open the things, it will be sum of xi minus sum of x bar up to n. Sum of xi is nothing but the sum of all this. This is nothing but n of x bar. Okay, is this? Pause a bit and think of it, then you will understand. And we can write it as minus n of x bar is the sum of the all the elements is, and this is, and this one. Okay, the value you get is 0. Okay, this is our first property. Next is property 2. Property 2, it says sum of the squares of the deviation taken from the mean is least in comparison to the same taken from any other averages or any other arbitrary values. So it is sum of squares of deviation taken from mean is least in comparison to the same taken from any other averages. Sum of the squares of the deviation taken from the mean is least in comparison to the same taken from any other averages. Suppose we have the same data x1, x2, x3, x4 continues to xn, and this average is x bar. So this is saying that sum of the squares of all the deviation. I just explained in the previous property that what is the deviation. This is the deviation. So the deviation from the mean then taking its square, then taking its sum of the squares of the deviations taken from the mean is least, means this value is always less from the value we get from sum taken from any other averages. Any other, suppose the observations minus any other averages, we think of an arbitrary value. This is an arbitrary value except mean. We can think of A as mod, as median, or any arbitrary value. Okay, this is the property 2. You need to take an example to understand this property. So taking an example, suppose an experiment. Test 5, 8, 10, 10, 6, 8, 9, 12, 13, 14, 15, 11, 10, 12, 8, 5, 8, 10, 10, 6, 8, 9, 12, 13, 14, 15, 11, 10, 12, 8, and we calculate the n value here is between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, now take sum of, I'm taking another page, so take off another page. Here we're considering sum of the deviations from the mean. You need to calculate the mean of the data first. So here we need to calculate the mean. So here x bar equal to sum of xi by n, that is 151 by 15, that is 10.06. Okay, now taking the squares, 5 minus 10, 0, 6, these are the observations, that 5 plus 8 minus 10, that is 10 minus 10, it continues and ends here. 8 minus, no, by not denominator. Calculate the values, 36, 24, 01, 00, 36, 01, 00, 36, again 2440, 52. We calculate this, it is 126.2375. Okay, so the next we taking an arbitrary value as a equal to, suppose 8. Now calculate this with the arbitrary value 8. Calculate this, 5 minus 8 whole square, 8 minus 8 whole square, 10 minus 8 whole square, 10 minus 8 whole square. It continues again, 8 minus 8 whole square. We calculate this, 8 or it is 0, 4, 4 up to 0. We add all this, the average value 177. You can clearly see here 126.9375 is less than 177. We can now hence prove that sum of xi minus x bar is always less than any other arbitrary value squares deviations. You can take up another examples and check. Now we will think of property number 3. So here we will introduce you with the two terms, that is the change in origin and change in scale. The change in origin refers to adding or subtracting a constant from every data point, that is the observation, which shifts the starting point of the measurement but does not change the spread of the unit of the data. Okay, it doesn't spread, change its. I will explain it with the property again. And the change in scale is multiplying or dividing every data point by a constant. That previous one is change in origin is subtracting something from the all the observations, and in this we divide or multiply something from the data point, a constant which changes the observations and the change in the measurement. Okay, so the third one states that uh, in arithmetic mean am is affected by both the change in origin and scale. Suppose think of an observation x2 x3 continues up to xn, and we think of a, a step deviation. So we think of a constant ui from which we will do all the observations xi minus a by h. We learned that the origin is nothing but the point we subtract. We do subtract, or in the scale we do multiply or divide thing. Okay, here we done the same. If we subtracted some constant with from the data points, it is said to be as the origin, and if we divide or multiply something with the data points, it is called the scale. Okay, this is the concept. So if we adjust it, so xi is nothing but ey plus h. If we were thinking why we do some constant minus and dividing something, this standardizes the observations. So you can if you draw a graph or something like that, you will get an standardized graph, that is good or better than the normal observations graph, because we are standardizing the data by subtracting and dividing, so that the data points will show variations, and the point of skewness or the point of diversity or the variations easily. So we can write as a by h plus a. Okay, so here if you think of what is h, h is the width, or we can say h is the difference between the all the data points from the previous one, and ui is the new variable after the standardization. A is the arbitrary value. Hello, arbitrary, and this is observation. So now if we put a summation mark in xi from I to n and summation mark from I to n hui plus a, we get again opening it hui plus summation of a to n, and here we are doing something like sum of xi y n equal to sum of I to h. H is a constant and ui is the variable here, by n plus sum of I equal to n from a. Then we can write this is the average or the mean. This is nothing but h ui's mean, and a is a changing value, so we can write is aha itself. Okay, this is the third property, that arithmetic mean is affected by both the change in the origin and change in scale. Arithmetic mean as it is both depending on the change in the two values. This one, this is the arithmetic mean, and this is depending on the change in the values. Okay, these are the two values, not this one. Okay, not this one, it depends on this and this. This is change in scale, change in origin, and arithmetic mean depends on this. Okay, it is directly proportional, we can say, but we will not write it yet. And we have last 10 minutes, so that the video will go up 1 hour. So let's talk about the merits and demerits of the arithmetic mean here itself. So merits and demerits of the mean. Here itself, merited it utilizes all the data points, and you need to remember this. Okay, these are not the garbage. Next point is it is well defined. Next point is it is easy to understand and compute. Next is it can be used further to calculate another mathematical things. Okay, like it can be used for calculating the standard deviations and variance and many more. We will learn more about it in the next videos. So the demerits are it is barely affected by extremely small or extremely large value. So if we think of an example 510 and 995, suppose these are marks of your class students, okay, and you take an average of this by 4, you will get 200 by 4, that is 50. The average is 50. Suppose think of the average placement of a college, or the marks also. Let's think of the placement. Suppose the college is showing the average placement is 50 LPA, but in the reality, two students got 90 LPA and 95 LPA, but another two got 5 LPA and 10 LPA, but average is showing 50. We think of that the way all the students are getting placed with 50 mark, 50 LPA. This is wrong. We can't find the mean in case of one missing value of x. Mean will be disturbed if there is any missing value of x. Okay, and it is generally got preferred. It is generally got no preference for skewed data. You will know what is skewed. Now I am saying in Hindi, it is एक तरफा झुका हुआ. Okay, suppose the data are like this, and the maximum observation points are supposing in the, if this is the mid value, this one, these are the most observation point are in the left side, so the mean will be in the left side, but these are also the points, so it is not preferred for a skewed data. Skewed data are affecting the mean. So there are three demerits of uh, the mean, it is affected by extreme large and small values, and it is not preferred for the skewed data that is highly skewed. Okay, add here, it is highly skewed. Highly, it can be skewed in the right side or in the left side, so the mean will be in the left side of the data, whether where it is skewed more. So the mean will considering only the skewed part, not considering the whole observation. So we must not use in the case of the skewed data, highly skewed data. And the third point is we can't find the mean in case of whether one observation or one element of that observation is missing. I think you need to do the whole thing in a great detail. Before that, in next 4 minutes, I am telling you another one thing of the mean, that is weighted mean. Weighted mean. Weighted mean is nothing but think of that our universal thing. Okay, universal example, having weight w1, w2, w3 up to wn, and here the weighted mean xw equal to sum of elements from I up to n. What we do in case of the frequency, we multiply the frequency with the number of the elements or the observations. Here also the same thing, we will multiply the elements with their weighted mean by their weights, as we do in case of the frequency. We take sum of all the frequencies in the denominator and the product of the frequency and the observations in the numerator. This is the weighted mean case. Okay, I think this is enough for this video. You must need to revise before watching the next video. These are, think of where we have started. We started with whether you know about what is frequency or not, and we reached here. Here we understood about the weighted mean, and the properties are most important. The three properties, you must remember those, and the merits and demerits are asked in the MCQ type questions too. So must remember, revise everything. It is very important. And this mean concept is also used in the further concepts like the standard deviation, the that one, its square is variance, and many more mathematical concepts. It is used in almost everywhere. You need to revise it. And also we will continue with the median part. We will see what is the median and how we calculate it. So mean is nothing but the average. You must remember this point. Mean is nothing but the average, and you need to remember from the beginning. In this video we covered, I am revising again, we covered group data mean, ungrouped data mean, and then we covered some examples, and we saw when we convert a group data from an ungrouped data, its averages changes and gives error. Then with properties of mean, then this weighted mean concept. So thank you for this video.